Okay, so we're going to pick up on page 2 of the sample exam test 1A. And if in the previous video we left off on problems 11 and 12, now we're going to continue with the normal distribution, except we're going to do a different type of problem. And for problems 11 and 12, we were given the area and we were asked for the area given a z-score. Here we were asked for the area given, in this case, 2 z-scores. Down here, the difference between this type of problem and the ones above is now we're given the area and we're asked for the z-score. And so we're going to use a different function on the calculator, and we're going to use the table differently. So if you're given the area and you want the z-score, you use the inverse norm function. That's the same if you're given a probability or given a percentile, and then you want to find the z-score. Or if you use the table, we just use it backwards. One final thing to note for both table and calculator is that we want the area to the right to be 0.15. That means the area to the left is going to be 1 minus 0.15. And both the table and the calculator give you the area to the left. And so that 0.85 is what we're actually interested in. So I can go to my table. And now remember, I'm using the table backwards. The areas are inside the table and the z-scores are on the outside. I was given the area. I want to find whatever's closest to the value. So I can find 0.85. That's the area to the left. So the z-score is 1.04. Hopefully that's an answer. And it is. B says 1.04. Or I can use the calculator. Now, instead of using the normal CDF, I go the same place, but I go down to number 3, inverse norm. I put in the area to the left, so I have to put in 0.85. And then I can just hit enter. And I get 1.04 when it's rounded. Okay, so it's very important for all the types of problems that we do to figure out whether you're asked for the area or probability or percentile, and you're given a z-score or vice versa. Okay, so let's go ahead and do the next one. The monthly incomes of trainees at local mill are normally distributed with mean of 1,100, standard deviation of 150. What proportion of employees earn more than $900 a month? Okay, so this is another normal distribution problem. If I do it by hand, I can calculate a z-score. I have to pay attention to the keyword more than, but my z-score would be 900 minus the mean divided by the standard deviation, which is 150. And that gives me a z-score of, I gotta do it real quick, of negative 1.33. Then I go to the table and I look up negative 1.33. Okay, so here's negative 1.3, 0, 1, 2, 3. That means that the area to the right is 0.0918. So back to my exam. But I don't want the area, the area to the left is 0.0918. That's an answer, but that's the area to the left. The table always gives you the area to the left. If my question has more than or greater than, I subtract from 1. So I take 1 minus 0.0918, and that gives me 0.9082. So C. I can jump to my calculator. Now, given a value for x, and I want to find the area under the curve, which is a proportion, so I go to the normal CDF function. Now I need to type in a little more information. I need a lower bound. Because this says more than, then my lower bound is going to be my value for x, so 900. My upper bound is just going to be a large number, so I usually type in 6 nines or so, comma, and then I always type in my mean, and then my standard deviation, so 150. And then I can hit enter. Okay, and I get 0.9087. The two answers are going to be a little bit off. Just go with whatever's closest. Okay, so let's get through the next problem here. We're just identifying whether things are sensitive or resistant to outliers. So we did a worksheet where we demonstrated this. The mean is sensitive to outliers. The median is resistant to outliers. You can change the min or the max. You can add as many zeros as you want to make the maximum larger. That's not going to have any effect on the median. The range is also resistant, or the IQR is resistant. That's Q3 minus Q1. Your outliers are going to be closer to your min and your max. The range is your max minus your min, so that's going to be very sensitive because your outliers will occur on your max and your min. Okay. So the next two questions, you want to identify whether something's an observational study or something's an experiment. The idea here is that an observational study is a study where you're not imposing any sort of treatment or you're not assigning a treatment to a subject. Whereas an experiment, the researcher assigns treatments to the subjects in the experiment. So the first one says a clinic gives a drug to a group of 10 patients and a placebo to another. So since the clinic is actually administering the drug, this would be an experiment. The next one says a sample of fish is taken from a lake and the pollution is measured. Somehow they're measuring the effect of the pollution on the fish. They're not imposing any treatment, and so this would be an observational study. Okay, so moving along, we are on let's see, we're given some data, amounts of time in months that employees have been working at a restaurant, and we're asked to identify or use the 1.5 IQR criteria to determine whether there are outliers in the data. So the 1.5 IQR criteria, what you're doing here is you're calculating two numbers. You're calculating Q3 plus 1.5 times the IQR. And you're also calculating Q1 minus 1.5 times the IQR. So those formulas, they'll be given to you on the exam. You don't have to memorize them. But the first step then is just to figure out the quartiles because we need those to get the IQR. And so the data is neatly arranged in two rows. And if you remember, Q1 is just the median of the first half of the data, so the median of the top row. And that's going to be 8. And since the numbers are lined up, then I know 70 is Q3. So Q1 is 8. Q3 is 70. You can get those numbers from your calculator as well. So the IQR is going to be equal to 70 minus 8. And that's going to equal 62. All right, and so let's go ahead and calculate this first. That's going to be equal to Q3, so that's 70 plus 1.5 times 62. Okay, and so what does that equal? That is equal to 163. And so anything above 163 is an outlier, so I can go up to my data set here, and I have one outlier, which is 167. And then I also want to compute the other one, so the Q1 minus 1.5 times the IQR. And so that's going to be 8 minus 1.5 times the IQR, which is 62. And that's going to be equal to a negative number. That's pretty common. And so there's going to be anything less than negative 85 would be an outlier. Of course, that's not relevant in this example. So we have one outlier, and that's 167. Okay, this is one of the more difficult problems, and it helps you identify the difference between the two types of problems. And so again, we want to look for keywords such as greater. Actually, greater than is in both of these. And so we're given that wing lengths of an African male finch varies according to a normal model with a mean of 61.2 and a standard deviation of 1.8. Find the probability that an African male finch would have a wing length greater than 64. So I could calculate my z-score for that. Z is going to be equal to 64, my value for x, minus 61.2 divided by 1.8. Okay, and that's equal to 1.56. And what I want to do now is go to my table and look up 1.56. Oops, go to the positive side. Okay, so I have 1.5 here, 0, 1, 2, 3, 4, 5, 6. So the area to the left is 0.9406. I'm going to go back here. If I wanted the length less than 64, that would be my answer. But because I want greater than, I subtract from 1. So my answer is going to be 1 minus 0.9406. And that's going to be 0.0594. Okay, I can go to my calculator and do this problem as well. So this is a straightforward problem. I go to normal CDF. I put in a lower bound since it's going to be greater than, my lower bound is 64. And then my upper bound is just a large number. And then I put in the mean, 61.2. And then I put in the standard deviation, 1.8. And I get a number very similar to 0.0594, so it's off by just a little bit from what we calculated by hand. Okay, so that's a straightforward problem. The next one's a little bit more difficult, maybe the most difficult one on the sample test. Here it says find the length such that only 6% of wing lengths are greater than this. So the difference between these two types of problems is here I'm given the percent and I'm asked for x. I'm asked to find x. Here I was given x was 64, and I was asked to find the percent. It says greater than, I still have to take that into account. What I want to do is first find a z-score for not 6%, but 94%, since that's the area to the left. And so I go to my z-score table, and I look inside the table for 94% or 0.94. And I get whatever's closest. And I could take either of these two numbers because they're the same distance from 0.94. So I'm going to go with 1.55. That's this number here. I'm getting the z-score that corresponds to 0.94. So back here, this is 1.55. Now I want to solve for x. X is going to be equal to our z value. This formula will be given to you times our standard deviation plus our mean. Mean is 61.2. And this then is equal to 63.99. And I can do that on the calculator. Calculator, remember this is a different type of problem. I'm given the area, so when I'm given the area or given a percent, I use the inverse norm. I always enter the area to the left, so that's 0.94. And then I would enter the mean, 61.2. And then I would enter the standard deviation. And enter. Okay, so I'll end the video here and then start on page 3 on the next video.